Good afternoon, everybody, and welcome to the very first Construction Technology Summit organised by KHL Group and its magazines International Construction and Construction Europe. My name is Alex Taylor. I'm delighted to be your moderator for this afternoon. We're going to be covering the very latest trends in machine control and robotics in construction equipment with 5 great speakers and a round table session. We'll also be taking your questions. But before we start, I'll be giving you a few housekeeping notes about the platform. But first of all, I'd like to introduce Andy Brown, who's the editor of International Construction, to say a few words. Over to you, Andy.
Great, thank you, Alex, and hello to everyone out there. On behalf of the KHL Group, welcome to the first Construction Technology Summit. We have more than 1,300 registered delegates for today's event, which I think tells you a lot about the level of interest surrounding the topics that we'll be discussing today, which are machine control, autonomous operation, and robotics. We are very grateful to you all for registering and taking part today, and we're also grateful to all our fantastic speakers who you'll be hearing from in the next few hours. Whether you are a manufacturer, dealer, or end user, we hope that these speakers will help you understand the current landscape and make more informed choices for your business. As Alex said, KHL's construction technology brand was established by International Construction and Construction Europe and includes magazine supplements, webinars, a dedicated website, a newsletter, and online events such as this one. Technology is one of the mega trends in the industry. And it's a fascinating topic that we greatly enjoy covering and will be doing more so in the future. This event would not be possible without our sponsors, and so our thanks go to our headline sponsor, who are Trimble, our silver sponsors, Stillwrist, Track Unit, and ZTR, our Supporter Plus sponsors, Pix4D and Smart Construction, and our supporting sponsor, who are Lawson's Construction Recruitment. We'd also like to thank the associations FIAC and CC and the exhibition ConExpo ConAg for being supporters of the event. Obviously, this is a virtual event today, but we encourage you to network with attendees and to ask questions. Alex will explain how you can do that in just a moment. We also have a dedicated networking session for 45 minutes at the end of the event. So that's it from me. I hope you enjoy this summit, and I'll now hand you back to Alex.
Thank you very much indeed, Andy. Well, before we go to the first speaker, I'd like to give you a quick summary of the program and a few words about how you can actually use the platform you're watching this afternoon. We will have 3 industry presentations followed by a short networking break, and then 2 final speakers and a roundtable discussion. With all this, we should be covering about 2 hours. At the end, because this platform will be remaining live, we encourage you to stay online for 45 minutes so that you can network using the chat and video call functions. Now, a few words about the platform itself. You will be watching this on the viewing box. If you want to maximize that, then you can click on the full screen option on the bottom right of this box, or you can click the pop-out option. If you use the pop-out option, that allows you to continue to chat or network whilst you're viewing and listening to the event. For networking purposes, there's a social wall, isn't it fantastic, which you could use to post messages or pictures, whatever you want. You can contact attendees individually using chat or video call options. That includes the representatives of the sponsors who'll be delighted to talk to you. To do that, go to the networking or attendee sections and search through the lists. There is also an exhibitor hub, which gives details of our sponsors, including their representatives who, as I said, are live with us on the platform. Next to the viewing panel, there are chat, question and answer, and poll buttons. The chat button allows you to send public messages to everybody who's watching, And the question and answer option allows you to direct questions to the speakers. The questions are moderated, so please expect a few seconds delay before they appear. So please don't ask your questions using the chat button because we won't see them. If you have a question, use the question and answer button. I hope all this is clear. Now, before we move on with the first speaker, we wanted to conduct a short poll with you. We have you all together, so it makes sense to ask you about some important issues facing the industry. We'll be having two polls today, and you will find the first one if you click on the poll button alongside the question, answer, and chat button. So you'll find it now. And if you could answer, the first question we'd like you to answer is, are you already using machine control technology? So I'll leave you a few seconds to answer that. Are you already using machine control technology? Yes, extensively. Yes, but not very much. Currently trialing it, or you are considering it. So please choose one answer, and we are going to have a look at the results in a few moments. So let's see how the results are going. Let me see if I can put this up. Well, that seems very clear that yes, extensively seems to be on about 50%, increasing, very much the leader. Currently trialing is the least replied to. So I think that's quite a clear answer. That's quite interesting. So you're already using machine control technology extensively. Right, so that's an appropriate lead in to our first speaker, who's Fred Rio from Caterpillar. Fred is product manager for construction industries, digital and technology. And your topic, Fred, is Caterpillar's vision for the fully autonomous construction job site. So please feel free to submit any questions at any time, and I'll put them to Fred afterwards. So over to you, Fred.
Excellent. Thank you, Alex. And thank you to the KHL team for having us here and giving us this opportunity to share our message. And we'll get right into it. All right, hopefully this can get our tech to play here. All right, so we're gonna start out with just very often I get questions from many, from many of you asking about autonomy. And you know, one of the reasons that there is so much interest in autonomy is really the fact that there's this intrinsic feeling that autonomy is going to unlock a lot of value. And so we can take a look at one of our sister industries, which in this case would be mining, to get a study case and an example of the kind of benefits that we can get from autonomy. So as you can see on the stats, they speak from themselves. Almost 400 trucks, 8 years in operation in 16 sites, running 24/7. And they've transported or hauled 3 billion tons over 110 million kilometers. And that's just the hauling piece. Of course, there's also underground mining, drilling, and dozing in terms of autonomous solutions. So there is a lot of value there, and the holy grail, really, what autonomy brings is all that productivity with safety, with the zero lost time injuries, and that's really the great promise of autonomy, is to bring both productivity and safety together. Typically, you have to choose either one or the other. So as I'll go through the next slide, but autonomy for mining was a very long journey. It did probably take about 20 years to go really from the start, the early days, all the way into having a commercial solution that could be scaled. And in construction, it's going to be the same thing. It's going to be a journey over time. And luckily, we've started that journey, and the poll speaks to it that many of you are on that journey. That journey starts with automation, and you increase layers of automation until you have machines that can perform certain operations in a autonomous mode, or maybe even fully automated or autonomous at a machine level. And at the same time, we need to make sure that all the machines, all the automated machines, and possibly the ones that are manned, are able to work together to automate the site. So really keep three concepts in mind from this slide. The first one is we're on a journey of increasing automation, which will lead to machine autonomy. But machine autonomy is only one of the steps on the journey. Really, site autonomy is the destination. And a couple of factors that have to be considered along the journey and that are going to really dictate the timing of the journey are where we're at on two curves. The first one is the technological curve. Of course, we need to have the technology to be able to enable autonomy. And you've seen that it's been a reality for almost a decade in mining. However, we can't just take that technology and bring it into construction. We are actually leveraging the next generation of technology that's emerging from automotive and bringing that new re-platformed autonomy solution into construction. The second one is really the adoption curve, and we have to make sure that we are on the journey to autonomy, bringing in incremental steps of value that you can pragmatically bring into your job sites without too much distraction and without too much disruption of your processes. So both is a technology curve as well as a adopter maturity curve. We can't just dump a fully autonomous site onto the market because it would take too much change management. So again, layers of automation over time that you'll be able to incorporate into your sites. So if you were to ask, what are the three ingredients for autonomy for construction? We'll break it down into three main components. So the first one is we're going to have to transform our machines into robots. And that's a journey that we've been on for a couple of decades or so. And some examples of that are, for example, full blade automation with grade control. That is really a semi-autonomous function where the operator is driving the machine, is displacing the machine, but the blade operation is fully autonomous. So, that is a form of an assist function, and that is exactly how automation is going to manifest itself, is increasing layers of assist for the operators. Eventually, those assist features will allow a task automation, and when we can automate several tasks, then we'll automate operations. The second piece is once we have machines that are semi-autonomous, or we have machines that can work or perform tasks on their own for some period of time, we will have to make sure that we can get the operator off the machine so that the same operator can then tend to several machines at the same time. And that's really where we've coined the phrase, turn the operator into a commander. And that is, that's an offering that is available today. We're debuting really this year, the command station, which allows operators to operate several machines of different sizes and different types and switching between them with just the switch of a button. So you can imagine, for example, if we picked the excavator in this image, and that excavator could auto trench, for example, for probably 15 minutes on its own before it needs some assistance from the operator. Well, if the operator's in the cab, then we really haven't maximized our operator's time. But by placing the operator into a remote setting that could be 300 yards or 300 miles away, now that operator can get the excavator auto trenching and then take control of another machine, possibly a manned machine, and now they can be operating two machines at the same time. If you exacerbate that example, you could have an operator possibly looking over a group of machines, maybe a whole mess hall operation. The third example, or the third component, is really job site management. So once we have robotized machines or robotic machines, we have the ability to control them remote. What we'll need is, we'll need the ability to synchronize all of the work that the machines are doing to achieve the optimum job site workflow. And this has really been happening for, again, the last probably 20 years. As we started with telematics, we evolved telematics into really what today is a job site twin. And then we're going to move from monitoring capabilities to predictive or prescriptive capabilities, and then eventually controlling the autonomous machines. So you can see in green is really what is commercially available today, and in blue is what we are developing. Again, with the intent of developing simple point solutions that you can deploy very easily into your job site without disrupting much of your existing processes. And then once you've been able to incorporate one of these technologies, then you can extend to the next one, to the next one, to the next one, and over time, turn your job site into an autonomous job site. So let's look at a short video that will show an example of how this could come to life. Let's go.
Caterpillar's roadmap to autonomy consists of three main technologies. Robotic machines capable of executing missions in full autonomy, the use of remote control capabilities to shepherd the machines around the autonomous job site, and a back-office software that creates machine missions in order to achieve the goals of the day. In the following sequence, you'll see how these technologies come together to enable a single person to use two machines simultaneously to perform a grading operation. The process begins as the project engineer creates a task for the field teams to execute. The task is later accepted by an operator who uses remote control to perform the grading operation using a highly automated tractor. The back office continuously monitors the progress made by the tractor. And as the tractor levels out enough ground, the back office creates a mission for the compactor to execute. The operator receives the mission and dispatches it to the autonomous compactor. The compactor receives the mission and determines how best to accomplish it. As the compactor begins to work autonomously, the operator takes back control of the tractor to resume grading. As he makes progress with grading, the back office AI will be sure to dispatch the compactor to follow. This illustrates how back office AI, remote control, and machine autonomy come together to enable a single person to operate multiple machines simultaneously.
Excellent. So I hope that video really brought together what we came up, this high level journey, breaking it down into the three components. And hopefully that video showed how a simple point solution that brings together several machines, an operator and a back office come together in a way that is simple and deployable into a construction environment without too much disruption of your existing processes. So as we look at the journey, we've broken it down a little bit into kind of macro blocks, and it started with machine control and guidance. So, if you were to ask, what do I need to do, or how do I get on the road to autonomy? It sounds like from the polls, most of you are already doing the right things and really starting to digitize your job sites. On the OEM side, you will see an increased release of features that are of this, automation and assist type. Remote control is a major release for us. It's a major stop on the road to autonomy, and it's something that for us is both unlocks value immediately, allowing you to be safer, to address a lot of your operator challenges, and produce more in many occasions. So that is a very important offering, a kind of a milestone for Caterpillar is moving into the remote control space. And that allows us to then develop and release many semi-autonomous functionalities on the machines, eventually have autonomous machines and then an autonomous work site. We like to think that, again, the future is now. At Caterpillar. We have distributed throughout the world our R&D and customer support capabilities around automation and autonomy, of course, driven by the journey that we've taken with mining. And then for construction, we stand again on their shoulders and are now well into our own journey for automation and autonomy in the construction space. So Alex, that's the content I had planned to share, and I turn it back over to you.
Right. Well, thank you very much indeed, Fred. That was very interesting. We have some questions which have come through for you already on the website. So if equipment on a job site is from different OEMs and different tech companies, will the equipment be able to talk to each other? If not, is this a barrier to autonomous sites?
No, absolutely. And that is that's probably an issue that we're going to have to tackle both as an OEM, and that is to deliver solutions that are compatible with the different, not only the different makes, but the different types of equipment that are on the job sites. Not all of them are made by Caterpillar. And we're also going to have to tackle that as an industry. And of course, it's going to take collaboration between the different OEMs to come up with solutions that are really site-centric and will work together to produce value for the industry.
Okay, another question. What are the legal ramifications with autonomous equipment? It's an interesting question. If something goes wrong, who is liable?
Yeah, that's certainly an aspect and a question that is on our mind. There are some precedents, of course, in the mining space. We are seeing different types of regulations in different parts in the world, and that is one of the challenges, is that it's really not homogeneous throughout. And while there isn't necessarily a legislation around autonomy in construction today, we're sure to see one soon. And then in terms of liability, that's something that's heavy on our mind, of course. There is somewhat of a perceived liability shift, so we're very conscious of that as we design the solutions. First and foremost, and it's very timely, one of the things that is on our mind is cybersecurity as well. That is another topic that is really kind of dominated the headlines and our minds lately. And luckily, our systems, because they've been conceived in a mining space, they've really been designed with cybersecurity in mind.
Okay, right. Well, thank you very much indeed. That was Caterpillar's Fred Rio. Very interesting talk. And thank you for answering our questions. So let's move on now to our second speaker. We're going to move on to a case study involving a US contractor using machine control technology with its heavy equipment. And I'm delighted to welcome James Arnold, who's Advanced Technology Manager at Goodfellow Brothers, a family-owned contractor working in Western USA and Hawaii. I think James is calling in from Hawaii, but the first part of his presentation will be in form of a video recording. But please ask your questions, because you can be assured that James will be with us live to answer them afterwards. So first of all, let's have a look at the video for the presentation.
Goodfellow Brothers is a family-owned business, fourth generation, and we're currently celebrating our 100 years of service. We have regions in all of the Hawaiian Islands, or throughout the Hawaiian Islands, Washington State, Oregon, and all throughout California. Our equipment use, as you can see, we're currently using Cat, Hitachi, John Deere, and Komatsu. So we have a wide variety of equipment that we have out in the field. And we're currently running approximately 61 excavators. We have 48 dozers, 21 graders, 10 rollers, and 22 scrapers. So we have a total of 162 wired machines, and this is changing on a regular basis as we rewire more machines as we go. So you can see that Goodfellow Brothers is really dedicated to utilizing machine controls on our sites. So using machine control in remote locations, I thought this was an interesting one to start out with, due to the fact that not only are you using machine control, but you are totally in an isolated area. So we did an infantry platoon battle course project on the islands, and I mean, this is out in the middle of nowhere. So just to give you an idea where we're at here, it's on top of the mountain, and it would take hours just to get to the site. And then once you're there, here we had our site. And to show you how complicated this site was, so our entrance to get there was all on dirt roads. And, you know, on military bases, you can only drive at 10 miles an hour. So it took you another 45 minutes after you got to the entrance just to get to the project site. So there was our first dilemma of just traveling and all that. So you needed to really make sure you had everything you needed when you got to the site. So then on the site here, they only gave us the 3 control points. So how are we going to lay this out so we could actually get a calibrated site? So we worked with the surveyors and teamed up our resources, and we decided to do static control. And so what we did was, there was no use of cell phones, there was no radios, I mean, no communications at all. And just to show you the extent of this project, I mean, they gave us the 3 points that were 5.89 miles, 8.04 miles, and 8.9 miles. So we literally had to pre-time everything, figure out, you know, how to get there. And this all on gravel roads, driving at 10 miles an hour. So we predetermined our start time, our stop time, and we set a few extra control points throughout the project itself, and then we were able to calibrate the site all within the computer in the office after gathering all our static control. So with that, we figured we probably saved about $30,000 to $40,000 just in how we set up the site. So here you can see our layout station, and at the upper corner, the upper left corner, you can see that little white dot. That's our actual antenna there for the GPS. We had power out there, and so it was transmitting out throughout the site. So here you could kind of get a rough idea of what the site looked like. So just try to imagine sending somebody out there on foot to stake out the road, or for anything for that matter, just sending somebody out there. So in this case here, we're able to load the model up into the machine. And one of the things I like to talk about also is avoidance zones. A lot of people don't know what they are or don't use them. Here in Hawaii, we use them a lot because we have endangered species. We have plants, trees, etc. We have grave sites, lava tubes everywhere that are, for some reason, an archaeological site inside of them. So we have to avoid those at all costs. So we're able to actually load up those zones into the machines. And so if the operator gets too close to them, it would literally turn the screen blood red and send out a beep and notifying that you're getting too close to these. So machine control was very critical to find these sites without actually having to go out and stake them and put up flagging around them and everything. So in this case here, we were able to literally just load up the site and or the site into the machine control, and the dozers were on their way grading the roads. And you can see here in the upper left-hand corner there, that's our layout yard. So that whole thing that you see there, all those roads, is what we had to build. So we had to use many repeaters out there. We would find spots up on a hill that we could get a phone reception or something like that to make a call. It was a very unique and challenging site. Here you can kind of get an idea of how it was on the layout and how the ground looked after we actually got it all graded out and everything. So you can kind of see the terrain. It's not a very friendly terrain to be sending people in on foot. So using machine control in this area just worked out great because, again, like I say, we just load the models up and the machines were able to go right to work and start laying this stuff out. And we didn't have to have somebody out on the site. Next thing I'd like to talk about is safety. Again, sending somebody out there to go lay out that center line or running topos out there or doing anything. Doing it conventional way out here in Hawaii is just really dangerous. You can wind up having somebody fall, break a leg. It could be really dangerous. So essentially, safety is a big thing that you save with machine control. Next one I'd like to talk about would be the 3D milling and paving. This job here, I'm going to call it just the Queen K highway widening. Please don't ask me to pronounce that. I still have problems with the Hawaiian names, but Queen K highway was another interesting project. It was basically essentially 5.2 miles of road, and we were taking an existing lane and adding another 2 lanes to that. So basically we had a north-south lane, and then we're adding 2 norths and 2 souths to that, as you can see in the photograph here on the left-hand side. So we essentially using, again, machine control, no staking, no nothing. We loaded up the machine, started grading the site, clearing it, and all using machine control. Again, safety is a major factor in using machine control because the operator sees exactly what he needs to see inside the machine and never has to leave the safety of the cab, and we don't have to have somebody out on the site staking hub and caps. And I remember laying out these roads like this with hub and whiskers, putting those out there every 25 feet. Those days are long gone, and we no longer need to deal with that. So here gives you a kind of example of what we were dealing with. So essentially, we had a existing road that had a crown of 2% on it. And what we're trying to do is maintain the existing asphalt structure, right? The integrity of the asphalt, and 3D mill it down. And so we're going to have an 1.5 inch lift on this, and then we can mill down from that down to get our cross slope of 2%. So it's kind of, for me, it was a little bit getting my mind wrapped around this, but essentially that's the plan there. But in reality, this is what the road actually looks like. So it's a lot more complicated than what people seem to say it is. So, because your 2% is never 2% after that road's been there for so long. So essentially what we're trying to get across here is mill it down so you can see in different sections like this. So we'll be able to 3D pave it then and fill those sections back up and have one continuous slope across the road. And basically everything was done in the office. So again, safety. Everything was done in the office. So we had an engineer. I was just the model builder for this site, but we had the engineer utilizing that formula that you see in the upper right-hand corner, coming down our 1200s there for our lift, our topper, and then figuring out how we could mill down and maintain the existing structure of the existing asphalt. In this case here, it took us 52 different areas that we had to remodel that surface and adjust it. And so we made a 3D model based on this with the 52 areas, which became one total surface, mind you, and loaded it up into the 3D milling machine. And so all the work was done in the office based on these formulas here. And then when we got out to the field, that we just loaded it up into the machine and the 3D miller just started to go to town. And this picture here always cracks me up because when you get out there, you got the operator, you got the checker, and then you got 12 others standing there watching, see how this is all going to work. Then here you can see we're starting 3D milling and everything's cruising. We actually had up to 10 total stations, and then the milling machine would leapfrog from one machine or from one total station to the next as we were going. And I was told that in the straightaway sections like this, we were averaging between 60 to 80 feet per minute of milling. And then we came back, and you can see here how we're using the same concept now. You can see the tower on there on the 3D paver. And so it was leapfrogging with the same total stations and everything, but we're 3D paving now, filling in each section and then building it up so that we could have that consistent 2% cross slope all the way across the road. So with this job here, we have an estimated savings of approximately $6 to $8 million. And there are a whole lot of other factors involved in this, but by us saving the integrity of the existing asphalt that was already there allowed us to win the project and save millions of dollars on doing so. And that would be the conclusion of that.
Well, that was great. And we're delighted to have James with us from Hawaii. Whatever time is it with you? It must be the middle of the night, James.
It's 4:30 in the morning here.
So either late night or early morning. Thanks so much for being with us. We have a few questions for you. First of all, you mentioned $6 to $8 million in cost savings due to using tech. Can you give us a bit more detail about how these savings were achieved?
Well, basically, like I was showing in the video, the original concept was to rip out the existing road completely and then rebuild it, which is 6 to 8 inches of asphalt there. It totally rebuilt, right? Versus 3D milling it down the way we did, we were able to minimize that asphalt that we have to replace and utilize the existing structure that was there. So in reality, it was a design build. So with the design build, we were able to adjust the elevations to match. And that's how we had to come up with 52 different areas of the surface.
Okay. In your experience, what are some of the most common factors that are stopping people from using tech?
They're afraid of it. It's, it's kind of like people don't want to update their newest softwares and stuff like that. I mean, if you think about back in the days when the guy had to go run down the street to find the nearest cell phone or the phone booth, right? Okay, nowadays everybody has their cell phones. It's just getting used to the new technology, and then once you have it, you can't live without it.
I guess we're all a bit like that. How did truck drivers feel about being loaded by unmanned milling machines?
Well, in their cases, as far as what the operators go, they're kind of intimidated by it at the start, but once they get into it and go in it, they have their display units. They just follow the screen, so they no longer have to have somebody on the site walk in or sit in the hubs like I was stating before. They just follow whatever's on the screen and they go. And then some of them have the auto switch where they can the machine will take over fully automatics, and all they have to do is just drive.
Okay, how does the company choose which tech companies to work with? What are the key things you're looking for?
Primarily, we're using Trimble products consistently, and we just find them to be the easiest to work with. And you know, I mean, they all do the same things, but we're using the Trimble products because of the simplicity, I guess.
Okay, how does Miller know when truck is full of millings?
That I don't know. I don't have to. I'm not the operator. I'm actually the one that builds the models. So.
Okay. And a final one. Due to the present situation with COVID, obviously an interesting thing to talk about. Construction activity can be a problem. How can we use technology to reduce the time, cost, and personal interactions?
Well, the good part about with the COVID is the only time we ever had our interactions is in the mornings when we do the tailgate meetings. But other than that, the individuals can be in the rigs. They don't have to be getting out like I stated before. They just jump in the rigs and go, and everything's done for them. If they have a problem with the site, they'd give me a call. I'd upload or change the model, re-upload the machines, and they're right back to work. And they don't even have to get out of the cab. So in that aspect, the operators didn't need to talk to anybody. Everything's through the phone.
Perfect. Okay, well, James, we really appreciate it that you've broken your precious night's sleep in Hawaii to answer these questions. Thank you very much indeed for the presentation and for being with us. Thank you. Right.
Thank you.
Okay, so for our third speaker before our midway break, we return to the world of manufacturing, in this case, Volvo Autonomous Solutions, the new autonomous transport business created by Volvo Group in 2019. And our speaker is Johan Holmen, who's Deputy Chief Technology Officer at the company. And hello, Johan, I think your topic is whole site autonomous systems, and you'll be answering questions afterwards. So over to you.
Okay, thank you. So fully driverless cars and businesses have taken longer and cost more than most expected. We are now in the year 2021 and they are not ready yet. So if everyone thinks autonomous vehicles are the future, why is there a delay? Solving the challenge of allowing autonomous vehicles to drive safely and efficiently on public roads is proving immensely hard. It is going to take more time before this happens. However, that doesn't mean that autonomy is not happening today. It is. So, hello everyone, my name is Johan Holmen and I am the Deputy Chief Technology Officer for Volvo Autonomous Solutions. We are a new business unit within the Volvo Group and we are dedicated to accelerating the development, commercialization and sales of autonomous transport solutions. We are already today offering autonomous solutions and we are starting with machines and vehicles that operate in controlled areas. By controlled areas, we mean mines, quarries, ports, and logistics centers. And here, autonomous technology that is available today can boost the efficiency of the operations and drastically reduce emissions. And on top of that, with driverless vehicles doing the work, improve safety. So in parallel, we are of course continuously working on proving efficiency and safety even in more complex use cases. But already last year in 2020, we launched Tara, and this is a complete transport solution for mines and quarries. This solution can manage transportation of large volumes in repetitive flows on predefined routes day in and day out without stopping endlessly if necessary. So one very important part of the Tara complete transport solution is the revolutionary TA15 machine. The TA15 machine is a fully electric autonomous hauler. Let me show you a short video to introduce this concept.
Isn't it funny how day by day nothing seems to happen? But when you look back, everything is different. That's the story of Tara. Volvo has always been on a journey, always evolving. Sometimes small steps are taken, sometimes big leaps. With Tara, we understood It's time to start something completely new and trust in the magic of beginnings. To try new things and not be afraid of failing. A group of talented engineers and designers brought our ideas to the table, supported them, and challenged them. After a while, the clouds parted and we could see where we were going. As our clarity grew, so did our confidence in this radical new solution. With collaboration and energy, our visions quickly came to life. This isn't just new technology, it's a whole new way of doing things. As cool as the TA15 autonomous electric hauler is, Tara is not only about individual machines, but a whole transport ecosystem that offers greater safety, improved productivity, much lower emissions, and a lower total cost of ownership. We failed at plenty, but we also learned important lessons along the way. As Albert Einstein once said, a person who never made a mistake never tried anything new. Welcome to the future. This is the story of Tara.
So autonomy is not a far-off ambition, it's available today. We have broken it down into smaller challenges based on the complexity of the ODD, or the operational design domain. So in these easier ODDs, there are certain constraints and conditions on the sites where the machines are used. And a quarry, for example, may only extend over a square kilometer in a clearly confined area with just a few haul roads. Controlling machines in this environment is different to solving the problem of autonomy on every road in a public network. When you can limit the scope of your operations, you can fast-track the technology development because you have a lower number of potential hazards the machines will encounter. At Volvo Autonomous Solutions, our goal is to lead the industry into more sustainable, safe, and productive solutions that both customers and the society will benefit from. This is about complete site transport solutions for autonomous applications. It is not about the individual machines alone. This opens up for new business models such as transport as a service. So a Tara transport solution consists of several TA15 machines plus their required infrastructure. This infrastructure can include charging stations, the autonomous driving system with its connectivity, and also connected cloud solutions. It also includes maintenance and repair support, safety infrastructure, finance solutions, and a manned control room to oversee the operation. To our knowledge, there is no comparable solution on the market today, with a unique combination of electrification, machine downsizing, and automation. The advantages that the complete Tara transport solution brings include greater control of operational costs, improved safety, process efficiency, as well as considerably lower environmental impact. Combining autonomous technology with electrification, as the Tara does, creates a very sustainable solution. In fact, the CO2 footprint has been reduced drastically, down to 85% or more on specific sites. When you consider that there are 25,000 quarries in Europe alone, the potential global environmental savings and efficiency gains are massive. So from our perspective, it proves Volvo's commitment to driving prosperity through sustainable transport solutions and infrastructure solutions. We are not driving this alone. Our customers are requesting our support to improve their transport tasks in their own specific applications and segments. We are in true collaboration with them to implement and optimize the individual Tara transport solutions. Efficiency, safety, and low or no emissions are high on both of our agendas. Tara can quickly and easily be adopted to worksite demands due to its modularity, flexibility, and scalability. Safety, that's part of our DNA. If the Volvo Group is known for anything, it's safety. The Tara complete transport solution includes state-of-the-art technology to ensure safety. Sensors like cameras, LiDAR, radar, IMUs, etc. They are combined with high-end computers, connectivity, etc. The TA15 machine itself uses lithium-ion batteries and a high-power conductive charging system, where a pantograph on the ground connects to a pickup on the bottom of the machine. The complete charging process is fully automated, and a typical charging time takes about 1 to 2 minutes per whole cycle. This emerging technology is not yet suited for all applications. Today, it works well in repetitive transport tasks where the consistency and accuracy increase the transport efficiency markedly. Quarries are a perfect example where repetitive haul cycles exist. There are still some challenges to overcome, and our customer trials of the Tara transport solution are giving us valuable feedback on how to develop the technology further. But we also need new legislations in a new autonomous world. Fortunately, there is already a good collaboration spirit with the authorities, and they recognize the need for the innovations that we are introducing. So, Tara is the here and now. But as I mentioned in the beginning, we are also developing autonomous technologies for the future, such as a hub-to-hub highway solution, etc. So technology will mature along with legislations and society acceptance, and we are working hard to demonstrate the efficiency, environmental benefits without any doubts in safety. The potential benefits from autonomous transportation is huge. Let me finish with another video that tells the wider story of autonomy from Volvo Autonomous Solutions. Thank you for listening.
Transport is the lifeblood of society, and we are at a start of a paradigm shift in transport that will reshape it. Our vision for transport in the future is one of highly efficient and integrated systems, connected infrastructure, and intelligent vehicles. We are therefore constantly researching and developing new innovative solutions that are safer, give increased productivity, and reduces environmental impact. Outside our cities, in semi-confined areas like harbors and dedicated autonomous truck lanes on highways, our research takes the next step to evolve innovation of autonomous trucks. The knowledge we gain will help us develop automated functions that fulfill our high safety standards. Connected to the cloud, we will link people, vehicles, and logistical partners, no matter where you are. It's never about technology for technology's sake. It's about how technical development can actually benefit customers and society.
Right, well, there we are. Thank you very much indeed, Johan, for that presentation. Lots of questions, just a few of them, if you could answer. How can this technology be transferred to other non-closed job sites, industrial complexes, residential construction? What is defining a closed job site?
In Volvo Autonomous Solutions, we are having, we have defined our safety levels, and I will not have the chance to go through them today, but we have certain levels that we are working on one by one, and the technology can for sure be used in several of those safety levels. But it's about proving technology and proving safety for each of them. That's also important.
Okay, how close are you actually working with other parts of Volvo on this, and what are the crossovers?
We are working very close to the whole group. We are like a startup in the big Volvo group, so we have tremendous support from the truck organization, from the construction equipment, from our process and IT. So all of Volvo is supporting us.
Okay, what are the priority applications for the new Volvo business?
We have divided our customers or potential customers into 3 segments. And as I have talked about before, it's the mines and quarries. And then we have ports and logistics centers. And finally, hub-to-hub highway solutions.
Okay, which of Volvo's customer segments, not just in construction, are the most progressive when it comes to autonomous technology?
Well, I would say that what I have presented today is the most progressive, the Tara solution.
Perfect. How closely is Volvo working with governments and bodies to make sure autonomous equipment meets the different requirements for safe use?
We need to work on every site we operate in. We are working very closely to get to get compliant and to get the permits we need and so on. But on top of that, since we are mainly focusing or currently focusing on Europe right now, the machinery directive is a very important legislation for us to adhere to.
Okay, the question's coming thick and fast. I'll ask you about 3 more. I believe the Volvo Tara system was first demoed as a concept in 2016, question mark. Is this now a commercial reality, or is it still being tested and trailed?
No, it is a commercial that we are testing. The machines have turned from green to yellow, meaning that is the construction equipment's sign of green machines are being under test, and now they are yellow, meaning that they are in commercial use.
Are the machines connected and controlled via Wi-Fi?
There are different connectivity options, and I don't think we will go into that, but we can use a number of connectivity options for that.
What is the comparable cost per ton calculation for this hauling solution from a TCO perspective?
That is for another presentation, or you need to contact me on that one outside, and I will connect to the commercial organization.
How are the batteries charged within 2 minutes? Did you mean that they are swapped?
No, they are not swapped. We use high power charging, so we have power optimized batteries for this.
Okay, as you're giving us such concise answers, I'll ask all the questions. How does Volvo plan to communicate with other autonomous vehicles in the same area?
We are, as I said, there are a number of connectivity solutions or options for us. And here the interface between different solutions is really important. That is an area that I feel is worked on in order to get good interoperability between many different solutions.
Okay, well, let's go the whole hog. I'll ask all the questions. Last question, will autonomy allow an operator to drive multiple machines at the same time?
Yes, a control room can be manned by a few persons or a single person and operate a whole system of the TA15 machines. Perfect.
Thank you for answering all those questions.
Thank you for asking all those questions. It shows that we are interested. So thank you.
Your presentation got people very, very reactive. Thank you very much indeed. That was Johan Holman of Volvo Autonomous Solutions. Now we're going to take a short break of about 7 minutes or so, so you can have a cup of coffee or a cup of tea, but please also during this time feel free to network with other delegates and watch the video. So let's say we'll see each other around about 5 past, whatever the hour is in your local time, so in about 7 minutes time. So we'll see you back at 5 past. Okay, everybody, if you networked and had a cup of tea or coffee, welcome back. We're ready to start again. Before I introduce the next speaker, let's have a second poll. Once again, you will see the questions and possible suggested answers by clicking on the poll button next to the question and answer and chat buttons. This time the poll is about autonomous operation of construction equipment, and the question is, what do you think is the main challenge regarding autonomous operation of construction equipment? Is it the reliability of technology, return on investment, safety, or is it the need for specialist IT skills? So let's let you play around a little bit like that. It's as we saw last time, the scores vary, but I think we're getting already quite attendance. Not much for IT skills, but safety definitely coming out as a major concern, obviously. Return on investment, the second, as we speak, safety shot up. Need for specialist IT skills, no, it's, as you can see, it's quite interesting. It's changing a lot. I think the fact that it's changing actually makes it quite an interesting poll. Yes, safety's gone back up. It's like you're changing your minds, but obviously clearly safety, the major concern. Right, before our next scheduled speaker, we're going to hear a brief statement by Riccardo Viaggi, Secretary General of CEC, the Committee for European Construction Equipment. Riccardo is going to give the CEC's view on machine data sharing, a topic that's highly relevant, obviously, given today's subject matter. Buongiorno, Riccardo. A lei.
Buongiorno. Good afternoon, everyone. Thanks for having me. Thanks indeed for having me, for having CC around this table. We are very proud and happy to be supporting this event, this summit. As you may know, CC is the industry association representing manufacturers of construction equipment in Europe. Through our national associations, we represent roughly 1,200 companies, employing 300,000 people and with a turnover of 40 billion euros. In a few words, let me highlight the way we as an industry body, as an industry organization, are trying to support the digital transition of the construction sector, starting from the machinery, of course. I believe it boils down to creating the best conditions for a competitive and forward-looking business environment that facilitates these technology changes. And actually, we start by almost disregarding technology. We try to look at other angles of this debate. And first of all, it's the user's uptake and the identification of coherent legislation. Basically, 2 points that were already highlighted in our first summit part. Our customers and final users indeed need to understand the power of data in solving their everyday concerns with job site productivity, sustainability, and safety. Leading rental companies and contractors, some have been presenting today, already see this business case, but the vast majority of construction sector stakeholders do not yet see that. They're not yet structured to see that, and sometimes, somehow, they're doubting the added value of data sharing. This is what indeed we have highlighted in 2018. We have carried out a study which is available on cc.eu website, and we see that it's all about the data. It's all about sharing the right type of data, and it's all about doing that according to the right models. For this to happen, collaboration and standardization are key, and these are also keywords which have already been mentioned today. We believe that this is indeed a role for the wider industry and for an industry body like ours, like we are. We believe that as manufacturers, we have a role to play, but also here, the word collaboration has been mentioned because machinery users should also raise their own awareness and develop with us the relevant use cases that can drive automation and autonomous solutions for the entire job site, which is indeed the end goal. As an industry association, part of our mission is to provide the venues for non-competitive industry dialogues and exchange opportunities. We do this regularly with the European Rental Association and are looking forward to doing it even more with contractors represented by another supporter of today's event, our friends from FIEC. We try to propose a shared approach by putting together all the relevant actors of the construction value chain. This is the idea behind DigiPlace, an EU-funded project to continue the development of digital industrial platforms for construction. We have developed through the project a reference architecture framework that should allow an organic development of local, national, and international digital platforms for the construction industry and all its very diverse business areas. Check out digiplaceproject.eu for more information on this. And if you are interested, you can connect to the virtual conference of the project on 27th of May. Last but not least, as a lobbying organization, we're monitoring the work of the European Commission on a possible new proposal, the so-called European Data Act, to regulate the way private sector industrial data are accessed and used in B2B environments. And of course, construction is on the legislator's scope. Our first thought on this connects to my first point about the centrality of data sharing. It is fundamental, we believe, for policymakers to talk about data sharing data sharing and access or usage rights. In the B2B environments with anonymized data, we do not believe it is useful to talk about data ownership. So we need to find the best ways to share those data, make it secure and trustworthy. Thanks for listening in a nutshell what we do in CC. I invite you to check our exhibitor booth and connect with us.
Okay, thank you very much indeed to you, Ricardo. And Mike Hayes, editor of Construction Europe. I think you'd like to have a short discussion with Ricardo.
Yes, absolutely, Alex. Thank you. We can't let Ricardo escape without coming back to him with a couple of questions on this issue. Ricardo, first of all, it sounds as though you're calling for or hoping to see OEMs working together on their use of data. Do you think this is realistic?
This is this I believe is realistic because it is necessary. It is something that we have already been doing. There are standardization technical committees which are already happening. This is after all the whole reason for industry associations like CC to exist. So it's one of our core mission. We have a role to play, as I said. We also believe that machinery users have to get involved in these arenas as well in order to make those business conditions, those standardization conditions even more profitable for them as machinery users, for them to understand the use cases and the business cases. So not only it is realistic, I believe it is necessary, and it is already happening.
Yeah, and I understand from yourselves and from FIEC, there are concerns about the amount of power that a lot of large tech firms are having, and growing power within the construction arena. Is that a concern? And if it is, what can be done about that?
I don't see this as a major concern. I think that the whole idea of opening up a somewhat traditional sector to new players can have a potentially positive effect. So we do see this as again, as a potential good news in order to boost that data sharing, in order to reap the new oil, this data being the new oil, and whatever company, whatever entity has an added value, a positive added value in putting forward the solutions for the transition of the construction industry, as a role to play in this. We first from the get-go, we would like to involve these new players, and we try to do that in our digitalization task force within CC, and we try to get that let's say dialogue going with a lot of other players around the table in our field. So that is, in my opinion, the way to do that.
Brilliant, Ricardo. Many thanks for that. And now I think I'll hand you back to Alex.
Okay, well, thank you very much indeed for that to both of you. Now we're going to move on with our program. A slight change, very last minute. Our next speaker was supposed to be Peter Lavery, the head of digital transformation for highways at Balfour BT, but unfortunately he had a problem this afternoon, an urgent problem he had to deal with, so he won't be with us. Our apologies on his behalf for that. So we're going to move on to robotics now. We're delighted to have with us Travis Schneider, who's Business Development Manager at RE2 or RE2 Robotics, which is based in Pittsburgh in the USA. Its robotic arm technology has been used on aerial work platforms and other equipment. And I think, Travis, you're going to talk about the use of robots and artificial intelligence systems on the construction of a solar park project. We're delighted you're with us. Over to you, Travis.
Excellent, and thanks for the warm introduction, Alex, and thank you to KHL for the opportunity to speak this morning. So overall, I wanted to address kind of the question that's posed on the introductory slide here. Is the construction industry ready for robotics? I tend to believe it is, and hopefully, I'll allow you all to draw your own conclusions, and hopefully at the end of my presentation, you'll believe me as well. I do anticipate there to be a lot of head nodding as I go through a number of the topics that I'm going to discuss. You all are going to think I was very well coordinated with, Fred and Johan's presentation. And believe me, we didn't talk before today, but you'll notice a lot of common themes, hopefully throughout my presentation. So just jumping right into the agenda. First, I'll discuss a little bit about RE2 Robotics, who we are, what we do. Talk about some of the key trends and motivations that I've heard from within industry. Again, I'm expecting a lot of head nodding as I go through some of those trends. And then I'm going to highlight some of the key features of robotic arm technology specifically. We heard a lot from equipment manufacturers this morning, but I'm going to speak specifically to some of the key features that I believe robotic arm technology should include in order to pursue these sorts of applications within the construction domain. As Alex alluded to, then I'm going to jump into one particular case study focused on solar plant construction. So I'll kind of step through some of the key value adders of robotic arm technology in that application. I'll then finish up by talking a little bit about some future applications that we see on the horizon, and then open the floor for any questions that might exist. So a little bit about RE2 Robotics. Our key mission stated here is to develop intelligent mobile manipulation systems that either empower workers to do their job safer or more efficiently, but ideally both, really. So we're trying to kind of thread the needle or arrive at the nexus of improving worker productivity and improving worker safety through intelligent mobile manipulation systems. And what I mean by that is not only robotic arm technology that can move through the world, so move through your construction site, but also be exposed to the harsh environment from a mobile standpoint, right? When we talk about mobile equipment, I'm also talking about mobile manipulators that can persist in that sort of environment as well. So as a company, we were founded in 2001 as a Carnegie Mellon spinoff. So for those familiar with Pittsburgh, it shouldn't probably come as much of a surprise that we're a spinoff from Carnegie Mellon University. And for the first part of the company's history, we were largely focused in on Department of Defense applications and explosive ordnance disposal. Well, that sounds very different from the construction industry. At the same rate, it's actually very similar in terms of the rigor of the technology required. So we've been, over our 10-year transitioning our technology from those DoD-facing applications to start to adapt to other sorts of challenging industries, construction being one of them. And then in terms of how we go to market, so it's really one of two ways. So first of which is we either sell component robotic arms that are mobile ready, again, ready for those outdoor applications, or turnkey custom solutions. And I'll feature one of those in the discussion today. And then the key verticals that we're focused on beyond the Defense Department are construction, aviation, energy, and medical applications. So why should the construction industry be focused in on robotics, right? So why are we all here? Why am I speaking? First of which, and again, I'm expecting a lot of head nodding here virtually, but we're dealing with an aging workforce where there's a wide variety of construction workers that are reaching, the end of their career, and they're taking a lot of those skills with them, and they're not being replaced by new younger workers, right? So there's a labor shortage, particularly amongst the younger generation. For those workers who are still in industry, we need to keep them in industry. being productive. So we want to avoid a lot of potential safety hazards. And then additionally, there's a lot of regulatory or compliance that's coming down from any number of governments mandating higher safety standards for these workers because we want to protect them, right? Next is, that given the competition across the globe today, there's a strive for enhanced efficiency and productivity. But at the same rate, a lot of construction is still done very manually today. So there's often a yearning for where we're going to see step changes in efficiency. And frankly, I think Johan alluded to it within the opening part of his presentation, but the construction industry has actually been a bit of a laggard when it comes to investments within autonomy and robotics. But, a lot of these demographic issues, a lot of these motivations are starting to tip the scales in the other direction, because a lot of these companies are recognizing that these newer technologies are potentially have the potential to really disrupt major industries, right? And in particular, the last year certainly taught us a lot about how when you have too much dependence upon manual labor to conduct a lot of these tasks, what that can do for you amidst a pandemic, right? So I, for one, believe that robotics and automation certainly have the potential to really disrupt the construction industry overall. So if you're considering robotic arm technology as part of your solution or a new way of performing some given task within the construction space, there's really 3 key features that I'd want you to focus in on when consulting with potential suppliers, right? So first of which is you want to focus in on outdoor rated mobile manipulation technology. So when you compare and contrast a mobile manipulator, that is a manipulator that's optimized for an outdoor environment, with typical industrial robotic systems. Typical industrial robots are used to having conveyance systems that present parts to the robot. The robot performs some task in a small cell, and then those parts is then shuttled out of the way. Well, that's not at all the operating environment within the construction industry. Within the construction industry, you actually have to take the robot to the physical task. So how does that change things? Well, first of which, you can't rely upon these, behemoth robotic manipulators to navigate this extremely cluttered environment to go to perform those tasks. So you need something much more compact and weight optimized to go and address a given task without sacrificing strength performance in the process. So you should examine things like strength to weight ratios as a means of measuring the ability of a robotic manipulator to perform a given task within that cluttered environment. You want to examine its environmental performance. So for instance, can it handle Arctic conditions? Can it handle conditions that are akin to operating within the rainforest amidst condensing humidity? Can it handle various forms of precipitation, salt fog? These are all considerations that have to be made for robotic technology that's exposed to what I call the real world, or the elements. Thirdly, is this technology power efficient? More often than not, those industrial robotic arms are plumbed into 480 volt 3-phase. They're siphoning off huge amounts of power. When you're operating on a fixed power supply, presumably from a set of batteries, you want to be able to be very power efficient so that you can perform those tasks without having to constantly recharge the system. Next, I already kind of hit on this, but you want that solution to be very compact in terms of its form factor. Often we're dealing with a very cluttered environment where we've got to operate around other people or potentially other robots. And then last bullet point here, but certainly not least, is you want your system to be bulletproof. This has to be robust in order to perform tasks within the construction environment. Next major topic is this robotic system has to be able to see outdoors. And while a lot of us take this for granted, it's a very challenging task from an automation standpoint. Again, comparing and contrasting the industrial environment versus the mobile environment, a lot of the computer vision technology that's been developed for the automotive environment relies upon clean, fixed indoor lighting. As soon as you introduce sunspots due to glare or shadows due to clouds, precipitation, a lot of those perception algorithms fall apart. So you need to rely upon someone who has experience in the domain of outdoor perception technologies to overcome a lot of those challenges. And then third, the third key area that I want everyone to focus in on is making sure that the technology is AI enabled. So much like I believe Fred and actually James alluded to it in his presentation as well, as you've got your model, but then you've got the real world that you have to deal with. And oftentimes the two don't necessarily coexist, right? So you need something that's going to be able to take that model and apply it to an imperfect world. So you've got to be able to adapt to changes in the terrain due to rocks that aren't necessarily a part of your 3D model. Something that's scalable, that's able to address a wide variety of componentry. So in particular, I'm going to talk about solar module manipulation. And while all solar modules more or less look the same, they do have their nuances, they do have their differences. Ideally, you want something that's able to scale across all of those different objects without having to kind of reinvent the wheel. And then the last bullet point there is oftentimes customers want something that's digitally traceable to ensure the quality with which something has been constructed. That helps prevent a lot of litigation long terms because we can digitally certify how a particular system went together. So as a fairly brief case study, I'm going to talk to one particular program that RE2 announced earlier this year. We refer to this program as OAMP. It stands for Outdoor Autonomous Manipulation of Photovoltaic Panels. This is a program that will be leading in conjunction with not only the U.S. Department of Energy, but also a wide variety of industry partners within the solar industry, where we're going to be improving worker productivity, safety, and quality when manipulating photovoltaic panels. So I'm going to speak to basically 3 different layers of value that we're providing in this application, and then give you all a glimpse as to what the solution will look like. So first of which, from an operator perspective, this is really demanding work. So for a given solar plant, there could be hundreds of thousands of modules that a worker is going to be placing. Each of those modules weighs anywhere from 55 to 75 pounds each, right? So if you can imagine day in and day out placing hundreds of thousands of modules, this is really physically challenging work, especially when you consider that these modules are 2 meters by 1 meter in approximate dimensions. So really awkward to try and lift. That, as well as the competition for these projects is fairly fierce. So these workers are constantly being driven to work faster and faster and faster. Ultimately, that leads to a lot of quality related issues, as well as ergonomic issues, while people are really trying to work at breakneck speeds when it comes to populating these plants. Next, speaking to the solar developer level, margins for these projects are razor thin. And when you examine all of the various costs with delivery and installation of these modules represents the #1 soft cost. That is the #1 non-hardware related cost of constructing a plant. When you examine the potential for robotically installing these modules, that holds a promise of making a real step change in efficiency that'll translate to real change in terms of the solar developer's bottom line, and also improve the ROI, which a developer will start to recognize revenue from this plant. So the faster I construct the plant, the faster I can turn it live, the faster I can start to make money as a developer. And then third, speaking broadly to society, solar is still a fairly expensive form of energy when compared to other forms of energy, presumably those based on fossil fuels. So by automating portions of the construction process, we'll also be making access to renewable energy a lot greater when compared to other forms of power generation. And additionally, there's a lot of mandates coming down from any variety of countries pushing for solar technology as being a new technology of choice as far as power generation is concerned. So what does this all mean in terms of robotics? So here you're kind of getting the first glimpse of the notional robotic system that we'll be developing through this OAMP program, which is basically going to fuse together computer vision, machine learning algorithms, customized end-of-arm tooling to grip those solar modules, an outdoor rugged autonomous manipulator, as well as a mobile elevating work platform provided by JLG to help manipulate those modules from their packaging and then place them onto their mounting points within the solar mounting hardware. So we've envisioned this concept to be basically a variety of different autonomous vehicles that are going to work in concert with one another. First of which is an autonomous working vehicle, or AWV, that's going to be responsible for the picking and placing of modules. And then secondly, there's an autonomous delivery vehicle that's going to basically act as a shuttle to present, if you want to call them, fresh solar modules to the autonomous working vehicle, such that there's not a lot of wasted motion. In a current state today, oftentimes modules are staged, and then workers have to shuttle individual modules, several, if not potentially 100 feet to their installation point. In our concept, we're going to bring the material right to the point of use and then optimize the rate at which the robotic system picks up and places those modules directly onto their mounting hardware. And we don't envision this as being the last place for robotic manipulation to make a serious impact on the construction industry. We also envision in the future there being at least two large opportunities looming out in the distance. First of which is any application where you're going to be performing work at height. So I've listed out a couple of key tasks that we've gotten some interest in. First of which is glazing or glass work, performing that work at height, welding, rebuilding of facilities, and then things as simple as inspection, like bridge inspection. Oftentimes when performing this sort of work, it's very challenging to get ropes and hoists to deploy people down to the area of interest. So we believe that by deploying even something as basic as a sensor via robotics, that we have the opportunity to make huge productivity gains and huge safety gains overall. And then we also have the opportunity to provide drop-in robotic drivers to existing implement. And this is technology that, again, we're helping to transition from the DoD space into the commercial space as well. So oftentimes people have large fleets of existing vehicles that might not have drive-by-wire solutions on board. So we can provide drop-in robotic drivers that can manipulate either the primary or secondary controls, such that operators can take a manned asset and make it an either teleoperated or fully autonomous asset long-term. So that's a couple of hints at where we see, the future of robotics going as well. So with that, I'll open the floor for any questions and leave my contact information up on the screen.
Okay, well, thank you very much indeed, Travis. That's a fascinating look into the world of robotic technology. You'll be in the round table in a few minutes' time, but a few direct questions to you. Quick answers if you can. How quickly has this tech developed? For example, is your company doing things now that wouldn't have been possible even a few years ago?
So I can't get into all of the particulars of our other commercial opportunities that we're pursuing, particularly around like the aviation industry. We're doing some fairly novel things, as well as in the medical industry. And I would say in both of those cases, the types of applications that we're working on weren't conceivable within the past probably 2 years for a couple of different reasons. One of which would be cost of computing wasn't there in terms of making these solutions cost feasible. And somewhat related to that, I would say, is also the cost of sensing. When you look at the cost of sensors today, it's just ridiculous at how inexpensive sensors are becoming. So that's also enabling us to fuse together multiple modes of different sensing technology to inform our autonomy algorithms on board some really high horsepower computing systems that are, again, very inexpensive and becoming very small. So it's really Moore's law, I would say, that's finally gotten us to the point where these systems can be commercially feasible.
Okay, how can we apply robotic in building construction, especially mechanical, electrical, and plumbing installation? For example, pulling the cables via concealed conduits. Is there any technology that works?
Boy, yeah. So that's a really interesting question. So the handling of flexible materials is often something that's very challenging in terms of robotic manipulation. I'll say that's a task we're very interested in. I think there's a lot of opportunity there for certain. So in terms of working with like harder materials like plywood, sheetrock, things of that nature, that's actually fairly straightforward from a manipulation standpoint. But when it comes to manipulating flexible materials, oftentimes that's where you might look to having multiple manipulators in order to perform the task. So yeah, handling flexible materials is certainly a challenging application, and that would be my recommendation, is leveraging not only one manipulator, but often two. If you think about oftentimes how a person conducts that sort of task, they don't, manipulate wire with just a single hand. Oftentimes they're using two. So we try to replicate that within our robotic technology.
Okay, what would you say would be today's barriers, obstacles for the application of robots and manipulators?
So I think Fred hit on some of this earlier, as well as James. But oftentimes it's just it's more of the change management issue more than anything. Oftentimes I think there's a lot of fear of the unknown. There's a lot of fear of robots taking jobs. But then oftentimes if you talk to the actual operators on the front lines, they're the first ones to actually embrace the technology. So I think it's more of the fear of the unknown. But if you can get in on the ground floor, working directly with the operators and explain to them how the technology is going to solve a lot of their headaches and a lot of their back pain, frankly, oftentimes we see those barriers come down rather quickly.
Okay, Wilmot Dixon, construction contractor in the UK, trialed robotic vests in 2018. Has the technology moved on since then? And if so, how?
I'm sorry, I'm not familiar with the question. You said robotic vests?
Yes.
I'm sorry.
No, okay, fine. There's lots of other questions. Is the cost of this very high, and is this a real barrier?
No. So again, cost of computing, already hit on that. That is falling with Moore's law, as well as cost of sensing is falling drastically. And then in terms of the manipulation technology, so RE2 is producing, mobile manipulators that are, cost competitive with, other sorts of industrial manipulators out there. So I, for one, believe that this is a cost competitive technology.
Okay, there's one that I must admit occurred to me when I was listening to you. Your application of solar farm construction seems a little bit niche. Doesn't it make more sense to apply robotics to mainstream tasks like bricklaying and painting?
Yes and no. So, I mean, when you look at solar farm construction, I mean, this is one of the fastest growing construction areas across the world. I believe there's something like 230,000 people performing this task throughout the globe today. And frankly, there's still a shortage of workers to perform this task. There's somewhere in the neighborhood of, I believe, 120, let me get the number right, 126 gigawatts worth of solar planned to be constructed in 2021. And there isn't enough people to do the task today. So these developers are having to stage these projects out even 3 years to allow for basically the capacity of manpower to catch up. So I wouldn't say that this is necessarily a niche area today. It's definitely a burgeoning topic of construction.
Two very short answers, but I find this interesting. Do you think the pandemic has accelerated the advance of this type of technology or not?
Absolutely. I mean, so, speaking from RE2's perspective, we grew not only in terms of, I guess, our revenue profile, but also in terms of our headcount throughout 2020. So much so we're having to kind of share seats between engineers. So robotics has definitely been a growing industry despite the pandemic.
Okay, and final question, can these robots operate completely autonomously or do they need regular monitoring?
So yes and yes. So there's often a continuum or a spectrum of autonomy that we often promote to our customers, where at the far end of the spectrum where you need direct human intervention in the loop, we refer to those systems as being teleoperated. There's definitely applications where that will still be the case moving into the future. And then there's also tasks that are more menial, more repetitive in nature, where you might be able to rely upon what we refer to as supervised autonomy, where the system's performing a given task in an autonomous fashion. But basically there's a commander, I believe is how Fred referred to their system earlier, or really a robotic foreman who's basically authorizing tasks to be conducted. And then in other applications, the system can just simply be deployed and perform a task completely autonomously. However, I think those sorts of applications are a little bit further out today, given the state of where state of the art is.
Okay, well, Travis, don't go anywhere because I think you're taking part in the roundtable, which is happening
Sure.
immediately now from RE2 Robotics. Thank you so much for having answered those questions. I'm going to hand back now to Mike Hayes, the editor of Construction Europe magazine, one of the KHL magazines organizing the summit today, because you're going to be hosting the roundtable. Over to you.
Yes, I am. Thanks, Alex. Good to be back. And good morning, good afternoon, and good evening to everybody out there. I think we have around 20 odd minutes left of the event, so we'll have to go quite quickly. But first, I should say a big thank you to the supporters of this element of the event, which is Trimble. Thank you very much for sponsoring this. And an even bigger thank you to the three speakers who we have back with us, Johan Holmen of Volvo Autonomous Solutions, Fred Rio of Caterpillar, who has very kindly stepped in at the last minute to be with us again, and Travis Schneider of RE2 Robotics. Thank you, gentlemen. Okay, so I want to talk, I think, about not just the potential for this kind of technology in construction, but maybe more about the challenges that we face to get autonomous equipment out onto construction sites. So if I can turn first to you, Johan, you already have autonomous equipment, as you've said, operating in quarries, in mines, and other controlled areas. But what do you think is the key challenge to getting that equipment onto the construction site? Johan, I think you're muted. The classic.
There. Can you hear me now?
Yes, Johan.
Sorry for that. Sorry, the question was the challenge of getting autonomy out there to the... and I would say that the more help the autonomous systems can get from conditions on the site, etc., by emergency stop system or things like that, that for sure makes it easier to start. But then our challenge is to grow our capabilities, our automation capabilities gradually. And by that, meaning that to start dealing with manual traffic or persons driving the other traffic, interacting with the autonomous systems, going into having vulnerable road users in the system, etc. So I don't know if that's a good answer, but it's a gradual step that I would say. Yes.
It is a good answer, and actually answers my next question, was whether or not you saw some kind of a technological breakthrough that would make a huge difference and really jump things forward, or you think this is the way it's going to go, as in an evolution of the technology towards that sort of, and it's about safety as far as you're concerned.
Yes, correct, and yes, that is my answer, that it will grow gradually, our capabilities.
And what about regulations? Obviously, this is a difficult question to answer because regulations will probably differ around the world, and Volvo is a global company. Do you think, are you targeting an area, for instance, are you targeting European regulations in terms of how you're working with authorities to get this autonomous equipment moved onto construction sites?
We are active in many parts of the world on this topic, but for the Tara solution that I presented earlier, that is, it's as initially a focus on Europe. And I touched on it earlier in the questions that I got, that for us then the CE marking or the machinery directive is very important for us. But as I also think I touched upon earlier, is that we do need to interact with the local authorities and rule makers of that area where we are operating in to get approvals for safety, etc.
Sure. Okay, Fred, if I could move on to you. Cat has a lot of in-the-field experience of autonomy and autonomous equipment. Can you give us some insight as to the potential productivity uplift that it can potentially offer?
Yeah, so I think if you're referring to mining, for sure, a lot of it depends on your baseline. It depends on the site that you're deploying into, and it also depends on the amount and the type of autonomous solutions. You know, Travis earlier alluded to a spectrum of solutions where you can go to level 0 to a level 5. We have seen gains up to 30%, right? And again, with safety, but that cannot be taken as a general statement. It doesn't mean that in all situations that is going to be the case, right? Again, it depends on certainly what type of problem you're trying to solve with autonomy. I can tell you, you could have gains of, you know, north of 100% if you're trying to do something that is impossible to do with a manned vehicle, that then you could do with an unmanned vehicle. And then, of course, there are many applications where you may even lose a little bit of productivity, but maybe for the gain of safety. So again, you have to really think about a spectrum and be very focused about what problem are you trying to solve. It is really not just a generic panacea. You want to apply technology in a very targeted way to solve a specific problem.
On that subject of solving a specific problem, I mean, you're working with this technology day in and day out, and as you say, you're doing it very successfully in mines and quarries. You know, you're moving a lot of earth. Is it a problem that you're trying to solve? Do you need right now to be moving this autonomous equipment into construction sites? Is that seen as a sort of a primary objective of CAT, or are you happy just evolving it as in the areas that you are?
Yeah, absolutely. Just like anything else that we do, really, you know, we are trying to be in lockstep with the customers, and what we're trying to do is trying to solve customer problems, you know, unlock value, and a lot of it is unlocked through technology and through autonomy, but not exclusively, right? A lot of it does come even from just broader services, change management, looking at the processes. And so technology helps, but is definitely not the only solution to customer problems. Is it a priority for Caterpillar? We do believe, obviously, that the industry is moving in that direction. So certainly massive amounts of R&D are being dedicated to automation, autonomy, electrification. We know that those unlock value, so that's where we focus.
Sure. And the construction industry, let's remember, is crying out for productivity gains.
That's right.
Having in the past 20 years, I think, gained maybe 1% in productivity compared with manufacturing, which is something like 3.6%. So it is the laggard, I think, as has been mentioned before. With that in mind, and looking back at one of your slides where you showed the timeline for maybe an autonomous work site in the 20s, is that a little optimistic, do you think, or do you think that's a possibility, given that the construction industry is crying out for it?
No, I think it's a possibility. Of course, what you have to do is you have to define the word site. In construction, a motor grader and a compactor working together, that's a site, as well as the massive site of the new Istanbul airport. So certainly there is a certain type and size of site that I do believe that within the next the close future we'll be able to automate. As you introduce more complexity, more different types of operations, then obviously it's going to be further out. I think that a completely unmanned job site where you drop off the machines, June 1st, you come back to pick them up August 30th, that's a long ways out. But certainly portions of the operation or of the job site, we could see within this decade for sure.
Right.
And if I'm to bolt on to Fred's answer there, I think one thing that's advantageous about the construction industry in particular is you are dealing with controlled sites, right? So going back to Johan's statements earlier around, the challenges with autonomous vehicles, one of the principal challenges with autonomous vehicles today is the fact that they're dealing with an uncontrolled environment, right? If it was solely autonomous vehicles on the road, it'd be one challenge, but it's the fact that we have to nest autonomous vehicles with manned vehicles that make it a real challenge, and just pedestrians in general. When you're talking about something like a solar plant or as Fred pointed out, an airport, you're dealing with a constrained environment where you're dealing with skilled personnel who are prescribed to a different set of rules than just the casual person, strolling around on their scooter or on their bike. So it is actually a bit more advantageous scenario given the control with which the construction industry can operate a lot of these pieces of equipment.
Sure. Okay, now Travis, before I come to you, this has sort of been done, and I'm teaching my grandma to suck eggs here, but I think maybe we should just define again the difference between autonomous equipment and robotic equipment in construction. So I'm thinking of it in terms of autonomous equipment being standard construction equipment, which has an operator removed, and robotic equipment specifically built for a purpose, unmanned. So given that, would you agree that the busy and complex construction site could be a better area for robotics almost than autonomous equipment?
So again, when you refer to there being a firm line between what's defined as strictly robotic versus autonomy, again, I'm going to point back to the fact that there's a spectrum, right? So there's 50 shades of gray in between there. But when you refer to what's more advantageous given the cluttered nature of these sorts of applications, I do think there are advantages, particularly from a safety standpoint, for autonomous equipment. Particularly if you can develop a really robust sensor stack. Oftentimes, like a piece of manned equipment, you're relying upon that operator to constantly keep their head on a swivel, to be constantly taking in information around what's going on within the world around them, whereas sensors don't really blink. However, there are a number of challenges associated with the types of environments that we're talking about. I kind of pointed them out earlier. For instance, glare from the sun might inundate a sensor, and then all of a sudden you lose sensory information from one particular sensor. Precipitation can have a lot of challenges. So if you got droplets of rain that fall on a camera, that can occlude its vision. So it's really key to have multiple modes of sensing on board a piece of technology to give you a constant stream of information so that the system can perform its task not only productively but safely as well.
Right. I'm focusing on that. What you say about the sort of cluttered aspect of a construction site. Now, if we agree on that it's a real challenge to autonomous technology, the use of off-site fabrication and other changes, adaptations maybe to a site? Is that maybe where we're headed? Not so much the technology changing, the site itself changing. Is that what we're going to see in the future, do you think?
Sorry, is that a question for me, Mike?
That is a question for you, Travis. Yeah, I mean, do you think a construction site needs to change as much as the technology?
So I think long term, potentially yes. However, I think in order for this technology to be adapted, we have to pose as little change as possible to how tasks are performed today, right? So if all of a sudden I'm to show up to a site and say, nope, guess what, guys, we're not using 2x4s and plywood anymore, I'd be met with a real aversion from the industry. You know, similarly speaking, within actually the solar example that I pointed to earlier, there have been other previous attempts, even 10 years ago, at automating solar farm construction. However, they relied upon proprietary like curbing systems or proprietary hardware to be used. And it was met with real aversion from the solar industry because everyone else was driving the cost of those components down. So that's where we're relying upon artificial intelligence and computer vision to adapt to existing componentry within the supply chain to make that change as easy as possible. Long term, once I guess the industry is warmed up to the notion of robotics helping to assemble componentry out on a solar farm, yeah, I think there is a potential for upstream efforts to facilitate even greater efficiency gains of systems being produced off-site. You know, particularly we can deal with heavier payloads because we don't need to rely upon people to necessarily facilitate the movement of these components. We might be able to rely upon more of the brawny aspects of robotics or equipment to manipulate those components.
Right. And one more very specific question for you. I saw in one of your slides the robot with the solar panel, placing the solar panel, and a little image of a man standing next to it, which was quite disappointing to see. Not fully autonomous equipment. Now, with this in mind, and I'm joking with you really, how clever is this technology? For example, can a robot like yours, does it know when it's running low on charge, and can it return to a charging point? Are we talking about that kind of smart technology now?
Yeah, so a couple different things there. So in the first iteration of the technology that we are deploying, we aren't necessarily looking at removing people entirely from the process. Again, the challenge is a labor shortage. We're just looking to augment the labor that exists there to take away some of the more ergonomically challenging or I guess less safe aspects of manipulating these modules up and over onto the racking system. I, for one, have gone out to a field and I've seen the construction process firsthand. This is particularly challenging work. So oftentimes people are running around not only with this module that's, again, 2 meters wide by 1 meter, and having to hoist it up about 6 to 7 feet up in the air, and repeat that process within about a 20-second cycle over and over again. They're running around with these short little ladders to gain access. So it's a real challenge from an ergonomics standpoint. So our whole focus is how do we first address the ergonomic challenge and the productivity challenge associated with moving those modules. We're still going to rely upon human labor to, for instance, wire the modules together, to clip them all together, to affix them to the racking system. But then the longer term, I do think there are opportunities for other productivity gains. To your question around how intelligent are these systems around knowing when they're low on charge, yes, the technologies there are ready for these things to autonomously go back to a waypoint to either charge or figure out how to bring more charge to the vehicle. These are all things that we have conceptualized.
Brilliant. Brilliant. Okay, a more general question, maybe for you, Johan. In terms of the role of autonomy and making construction more sustainable, how big a role do you think it can it play in construction today, and can that role grow in the future?
Absolutely. The electric site that someone had a question about, it had a 70% energy cost saving. It had a 40% operator cost reduction and a 98% carbon emission reduction and a 50% fuel efficiency gain. So the gains are massive that we can get out of this technology.
Wow. And Fred, would you echo that in what you've seen with your autonomous equipment?
Yeah, absolutely. And it takes the technology and the process changes that you alluded to together. I think it's not only what the technology does, but it's more what the technology renders possible. You know, really reinventing the way things are done. And you know, those effects compound on each other in all dimensions: productivity, efficiency, energy, and so on and so forth. And
Right.
I know safety was a big concern from the poll. I think safety as well.
And finally, an open question really about if a contractor is interested in getting into this autonomous technology, what is available for them right now? Is there technology that's available right now for use on construction sites, or are we talking about future tech?
Who's that question for?
Well,
I'll take it.
You, Fred.
Yeah, absolutely. So as I spoke about, you know, some of the automation on the machines takes the form of assist functions. Today, the most practical form of technology on the way to autonomy for us is really the remote control station. Actually, I think today we are in Japan displaying machines at a trade show, and the machines are running in our proving grounds in the United States, and that's all being done live. So that, without having to look for much further automation, really unlocks a tremendous amount of value that you can bring into your job site in a very simple way. Of course, the hauling solutions for the upper end quarries and mining are a reality, as well as the automated dozing and some of the load and carry applications as well. Probably not suited yet for a very dynamic construction job site, more of a stationary job site that maybe could be a landfill or quarry or a mine, where you can actually invest into the infrastructure and the processes and then take advantage of them over time.
Brilliant. Okay, thank you. Let's have a look at a couple of questions that are coming in. One here: does Travis see his robots working immediately alongside humans on the solar farm?
Yeah. I mean, so as soon as we validated the process of manipulating those modules, that has been our intention, is to incorporate a collaborative robotic solution where humans will be working kind of hand in hand with the robotic solution to construct solar farms. So yes, absolutely.
Okay, thank you, Travis. Okay, how do we help contractors decide which technology to invest in that they will see good return on, and technology that can be reused? Maybe Johan, could you take that one?
Sorry, could you please repeat?
How do we help contractors decide which technology to invest in that they will see good return on? That's a tricky question.
Yeah, it is really, because I think it is really some sites or construction sites that we have been talking about, they are better suited than others. So no, I will give a quite vague answer on this one, because I do believe we need to sit down with that customer, with the customer to really look into the specific case.
Sure.
Yeah,
okay. Go on.
I was gonna try to answer that, Mike. From my perspective, I think there's two key attributes that we see across construction-related applications that have good ROI. One of which is the task fairly repetitive or mundane in nature, and then secondly, is there an access challenge associated with that application? So repetitive nature, I think you hit on already with regards to not only solar module placement, but brick lane, something very mundane and repetitive. And then from an access standpoint, does it pose a potential hazard to the operator to get to wherever they need to perform this work. So notionally, are they performing this work at height?
Sure.
Look for applications that are dull, dangerous, and dusty.
Ah, the 3D.
Yeah, the 3Ds of robotics.
That's right.
Good point, Fred.
Okay, here's another one for you then, Fred. When the remote operator takes over, are there any problems with the latency in sending commands?
Yeah, so there is, obviously we've been studying this for a long time. Typically, once you get past the 150 millisecond to 200 millisecond return trip for the data, that's where you start getting enough lag that the operators then at that point, it more than not being able to work, it starts bothering them, the fact that there's a lag between their action and then the visual reaction. And it's more of, I guess the way it's been explained to me, it's the brain refuting the lag between the action and the reaction. So as long as we can keep it below that threshold, it seems to be working fine. We have really good acceptance. And so the next question is, can you keep it below that threshold? So far, successfully, we've done, like I said, intercontinental tests, and it is not a problem. Now, I would have to say it's not like you just plug and play. If you are looking to go such vast distances with remote control, you are going to have some dedicated IT to set up some preferential networking. If you are closer point to point where you can use direct Wi-Fi direct, then in that case, it's typically not an issue. So it definitely can be done from anywhere in the world.
And finally, the big picture question: where do we want to be as an industry with autonomous equipment in, say, 10 years? Are we? I know you see in your slide. In your slide, you showed an autonomous worksite. Are we thinking in simple terms an autonomous worksite?
Yeah, I think in 10 years, right? I would definitely call it a success for all of us that are around the table today. But I would bring in as well, the governing bodies and our customers, is if we had enough acceptance to where we are seeing, again, portions of the job site being carried out autonomously or semi-autonomously on a wide scale, right? I think that would be definitely a success. Again, the dream of the whole site is going to take a lot more time, but I'd be really disappointed if, by the end of the decade, we weren't able to electrify and automate routinely on job sites. I would say, to everybody too, one of the things that's always on our mind is safety is going to be paramount. We are going to have to be interacting with humans on the job sites, man machines, and a mistake by any of us is a mistake for the whole industry. It could set the whole industry back a long time or a long ways. So that is something that we're very conscious of.
Sure. Brilliant. Fred, I appreciate that. Appreciate your answers. Thank you, Fred. Thank you, Travis. Thank you, Johan. Appreciate your time. And now I'll hand back to you, Alex. Thank you.
Thank you very much indeed, Mike, and thank you to all of you. It's certainly a very interesting discussion and lots of questions. Just to let you know that there will be a recording of today's events, which will be available to view on this platform very soon. So you will be able to rewatch particular sessions or view the PowerPoint presentations. Thank you to all our speakers today. They all did a fantastic job. I've certainly learned quite a lot of things myself. And once again, I would particularly like to highlight and thank our sponsors, the headline sponsor, Trimble, the silver sponsors, Steel Wrist, Track Unit, and ZTR, supporter plus sponsors, Pix4D and Smart Construction, and supporting sponsors, Lawson's Construction Recruitment. If I could also remind you that you are invited to stay on the platform for the next 45 minutes or so to network with fellow attendees. You can send chats, messages, or make video calls with other delegates, and the platform will be remaining live for the rest of the evening and for the following days. So it's been fantastic hosting this event today. And so on behalf of KHL International Construction and Construction Europe, thank you all very much for attending and for your questions. Have a great evening or afternoon or morning if you're in Hawaii. Anyway, wherever you are, thank you very much and goodbye.